Good afternoon, students. Good afternoon once again. In the previous class, we completed the syllabus with the pulse modulation schemes. Okay, that is the last chapter. Okay, today we are going to discuss about some old questions with you. So I given some sort of questions here. So including of all 5 units. So let us see. These are the probable questions. Important questions, the examination point of view. So there are most 30 questions are there. So see that the first one is state and state the need of modulation. State the need of modulation. What is the modulation? So what is the need of modulation? Already we discussed the top in the first unit. Okay. So compatibility of the antenna is one of the important concept in for modulation, and noise is reduced, and so all I covered the material for that one. So please go to the material ones. So one of the important question is need for modulation. State the need for modulation. So most of the times examiner specify the question. Here, the second one is state the frequency range of the following. So already given the list of frequencies. So and applications also. So the first class given a tabular column for very low frequency, high frequency, medium frequency, all those things are given now. So please see that table and set the frequency range of the following. High frequency, what is the range, and given what is the application of the high frequency also. Low frequency and voice frequency. So can you give the what is the voice frequency? For the voice frequency. So in the AM modulation, we prefer so the voice frequency should be the 4K, 4.5 or most 4K is the voice frequency. It should be in the telephone communication. Use the 4K range is a voice frequency range. So see that, and third one is compare full duplex and half duplex on the following points. Okay, definition and sketch and example. So what are the full duplex and what are the half duplex? Simplex, half duplex and full duplex are there. Those are communicating transmitter to receiver. If it is a simplex, so you have to send the message and you have to receive the message. That is the one-way communication. That is the simplex. So it is the half duplex means, so you have to send the message from transmitter to receiver, and also the receiver send the request and also the message. That is the both the way communication. Both the way communication. In the single attempt. So both the way, and you can send the transmitter message to transmitter to receiver, and again receiver to transmitter. So once you have to send, and once you have to receive. Whereas the full duplex means simultaneously you have to send the transmitter and you have to receive the You have sent the message from transmitter and you have received the signal from receiver simultaneously. Simultaneously, you have to both transmitting and the receiving it. You send the message and receive the message in the simultaneous way. That is the full duplex. So this is the directional capability of the communication. Directional capability. So that is simplex. This is the only one-way communication. Half duplex. So both the way communication. Then the full duplex, both the way simultaneous communication. That is the concept. Okay. The simplex is one-way communication. So half duplex is both the way communication. Full duplex is both the way communication simultaneously. So that is direction capability in the transmission. Direction capability in the communication. Okay. So that you have to define on the sketch and example to see in any material. So the fourth one is draw and explain block diagram of communication system. Draw and explain block diagram of communication system. What is the communication system? Communication system consisting of transmitter, channel, and the receiver. So this is the communication system. Okay, now the communication system, the transmitting end, there is a okay. Okay, sure. Yeah. So the fourth one is draw and explain the block diagram of communication system. The communication system source emit the signals, and the source is given to an encoder. The encoder output is given to the modulator. The modulator output is given to a channel, and channel output is given to the modulator. Demodulator output is given to decoder, and the decoder output is given to destination or sync. This is the block diagram of communication system. Once again, already explained in the previous first classes. The transmitter, channel, and receiver all together called as the communication system. System means along with the transmitter, receiver, channel. Now in the transmitter block there is the source encoder, and the modulator within the transmitting end. After that, signal is given to a channel. That modulated signal is given to channel. The channel output is given to demodulator, and the demodulator output is given to decoder. The decoder output is given to sync or destination. This is the communication system. Okay, so please explain each and every block. What is the source? Source is the signal or the message going to be sent, and the encoder is going to digitization version of the signal, message signal. After that encoder, given the modulation, you know the modulation process. So for the after modulation, so given to the channel have the where the noise is added. After the channel, output is given to the demodulator. The demodulator is nothing but opposite version of the modulation, and the demodulation output is given to decoder. So the decoder is given to sync or destination. Okay, this is communication system block diagram. Okay, and the fifth one is state and explain concept of transmission bandwidth. Okay, what is the transmission bandwidth? So bandwidth is nothing but F2 minus F1. The transmission bandwidth is depending upon the modulation scheme. We have to define different types of bandwidth. If it is a amplitude modulation, the bandwidth is 2 into Fm. If it is frequency modulation, the bandwidth is 2 into beta plus 1 into Fm, or 2 into delta plus Fm. So that is the bandwidth. Okay. Next, the sixth one is explain different types of noise involved in the communication system. So there is internal noise, external noise, and man-made noise, and there is short noise, flicker noise, and thermal noise, and transit time noise. These are the types of noises already explained in the last unit. Please go through that once. So seventh one is draw the frequency spectrum of AM. AM spectrum. The spectral components of AM is so FC carrier frequency, FC plus FM is upper sideband, FC minus FM is lower sideband. There are two sidebands are there. Upper sideband FC plus FM, FC minus FM is lower sideband. So the spectral components are there. Please go to the ones. And eighth one is give AM signal spectrum in time domain. So whereas in the time domain concept, the signal is FC plus FM and FC minus FM is frequency domain. In the time domain, there should be envelope. Envelope is active. The envelope is maximum and minimum is there. The envelope is maximum and minimum is there. That is, the envelope using modulation index is V maximum and C minimum by V maximum plus C minimum. So that is the envelope. Okay, in the time domain, you have to draw the envelope. When the envelope is apply the Fourier transform, that is converted to frequency spectrum. That is spectral component. Okay, so the envelope ఏమవుతుందంటే V maximum, V minimum values వస్తాయి. So that is M less than equal to 1 or M is equal to 1. So M greater than equal to 1 is overlapping. Okay. M of the signal have to be superimposed on the carrier. Then the carrier amplitude changes according to the modulation signal changes. There appears the envelopes. The envelope is positive peak and minimum and maximum is there. Minimum and maximum there. According to the minimum maximum, can derive modulation index. And it's called maximum swing, maximum plus swing. Okay. So like that is the time domain concept. Okay. Now ninth one is give the advantages of digital communication. For the digital communication, broadly say that the digital communication noise is less and accuracy is there, and bandwidth is less, and power is less. All those things are given, and most of the important term is the given more clear. So clarity is there, and power is consumed less. And the previous chapter can explain that. Suppose you have to transmit the analog signal, we required 30 to 60 dB power is required. If the same information is the digital domain, 10 to 12 dB is enough. 12 to 1 dB nature. Such a way that the power is reduces. The accuracy and power is reduces. The power okay. Sorry for the disturbance. Okay. So the when where you are now? So now explain different types of noises involved in the communication system. So please put that noises are there, different types of noises. And the seventh one is draw the frequency spectrum of AM. Already can FC plus FM and FC minus FM. That is the spectral component. When the signal have time domain, then you can apply the Fourier series and then Fourier transform. Then that is converted to frequency domain. That is frequency domain conversion called as spectral components. Okay. Now the ninth one is given the advantage of digital communication. Okay. And the 10th one is, so this is the problem. Already this problem is explained in the first chapter. That is 10 kilowatt carriage is amplitude modulated by 2 sine waves to a depth of modulation is 0.5 and 0.6 respectively. Calculate the total power and calculate the modulated carrier. You know that formula, that is total power PT is equal to PC into 1 plus M square by 2. You have to use that formula. That carrier power is given 10 kilowatts and total power is you have to calculate. It is equal to 10K into 1 plus m square into this. M is equal to 0.5 here, that is 50%, and 0.6 is 60% the modulation index. Modulation index is m, that is less than 1 is there. Okay. Already first class, the first unit I can explain this problem. This type of problems. Please go through that one. The 11th one is define the following terms with respect to FM. So this is FM modulation. Up to this amplitude modulation, the first unit, you can go for the second unit. Second unit is 11th one is define the following terms with respect to FM. That is frequency deviation, that is the del F, and modulation index, that is the beta, deviation ratio. Okay. What is the del F? Frequency deviation. How much frequency is deviated from the carrier frequency? Okay. That the phase deviation is there and frequency deviation is there. The frequency deviation, how much frequency is deviated from the carrier frequency? And 12th one is give mathematical expression of FM wave and given the meaning of each terms in it. Okay, can give the mathematical expression of the FM. What is the FM? V of t is equal to AC cos omega Ct plus phi of t. Okay, what is the mathematical expression of FM is V of t is equal to AC cos omega Ct plus beta sin omega m of t. AC cos omega Ct plus beta sin omega m of t. Where the beta is modulation. Okay, so see that one. And the 12th one is draw the frequency domain representation of FM. Frequency domain representation. There is spectral components are there. There is infinite number of sidebands are there. So go through that one. The 14th one is compare narrowband and wideband FM. What is the narrowband and wideband FM? Depending on the band modulation index, beta less than equal to 1 and beta greater than equal to 1. Beta less than equal to 1 narrowband FM, beta greater than equal to 1 wideband FM. So depending upon the modulation index of the FM, you can derive the narrowband and wideband. Okay. Some sort of concepts are there depending upon that. And 15th, draw the expression of PAM generation system. The PAM, the pulse amplitude modulation is nothing but the natural sampling with other pulse amplitude modulation. Okay. Draw the neat diagram of PAM, PPM, and PWM. The last class I given some waveforms are there. Please go to the waveform. PAM is pulse amplitude modulation, and PPM is pulse position modulation, and PWM is pulse width modulation. So this is the analog pulse modulation schemes. The pulse modulation schemes, the pulse amplitude changes according to modulated signal, that is the PM. Pulse position changes according to modulated signal, that is PPM. Pulse width modulation, pulse width changes according to modulated signal, that is PWM. So PPM is generated from the PWM. So not directly generated PPM. So it is indirect method of generation. 12th one is explain the effect of modulation index AM, AM wave is allowable modulation. M is equal to 1 also allowable modulation, provided that ideal low pass filter is decided. M greater than 1 is not allowable modulation. So that is allowable modulation means at the receiving end can recollect the signal originally. Okay, and not allowable means so some sort of signal is missing there. So that is M less than 1 condition should be the allowable modulation. M is equal to 1 is 100% modulation. 18th one is explain the effect of modulation index AM. Modulation index AM with already saw. No? 18th one is derive the expression for total power relation AM. AM the power relation derivation. And 19th one is compare high level and low level modulation AM. What is high level modulation? The high level modulation is the modulating signal is okay. It's only antenna to radiate. Whereas the low level modulation is signal is so some type of disturbance factor is in that 15th one is brand explain PAM generation system that is straight away can explain the pulse natural sampling process. The 16th one is draw need diagram for PAM, PWM, PPM. And 17th one is explain the effect of modulation index in AM wave with waveforms. Okay. And 18th one is derive the expression for low level modulation, high level and low level modulation for AM. And 20th is sketch the labeled carrier diagram of collector modulated class C per ampere is AM signal generation. That is the 20th question is straight away can explain about uh, collector modulated method of AM generation. The AM generation, there are two methods now. One is square law diode modulated method, and second one is collector modulated method. There is square law diode modulated method is low layer modulation, collector modulated method is high layer modulation. So please go through that once. And next question is compare AM and FM with minimum 5 points or 8 points are there. So please, I provide comparisons of AM and FM. Please go through that once. And next one is explain varactor modulation method in AM. Sorry, it is varactor modulation method where it is used now, not in AM. It is FM there. So question itself some sort of wrong, no? So in FM only, varactor modulation method is in the FM. How many types of generation methods are there? Parameter variation method, this is direct method of generation, and Armstrong method of generation is indirect method of generation. So this is varactor method modulation method is the parameter variation method. So straight away we can explain that. And next one is describe preempsis and deempsis in. So preempsis before modulation is used and deempsis is after demodulation. If preempsis is nothing but high pass filter, deempsis is the low pass filter. Okay. Next. The frequency modulation signal is represented in the this is the problem. Modulating frequency, maximum power deviation, what power will be the FM wave displayed in 20 ohm resistor. Already this problem may explain in the first chapter, second chapter. So next one is compare PAM, PWM, PPM. With waveforms you have to do the comparisons. The next one is define with diagram sensitivity and selectivity. What is the sensitivity? Ability to respond the weakest signal sensitivity. Selectivity means ability to reject unwanted signal. Ability to reject unwanted signal selectivity. Ability to respond the weakest signal is sensitivity. Fidelity means ability to receive the multipath signal is the fidelity. So please explain all these things. And next, state the type of AGC with characteristics. AGC means automatic gain control in the AM receivers. Okay, next one is sketch and explain TRF receiver, that is tuned radio frequency receiver. So there is a block diagram. So the first block is radio frequency amplifier, and there is a demodulator, and again audio amplifier and loudspeaker. So block diagram is there. Please go through the. And next one is why the limiter state is used in before detection, also before detection, also the value of IF for AM and FM radio receiver. What is IF? Intermittent frequency, or how much it is? Intermittent frequency is AM is 455 kHz. Intermittent frequency FM is 88 to 110 MHz. The next one is state need of AGC with characteristics. So automatic gain control characteristics are there to be explained. The last one is what are the disadvantages of superated and receiver. Okay, superated receiver are also one of the important question. So with these questions, please prepare. I can explain further in the next class. Okay. So thank you, Ananda.